Hey, pre-calc students, Mr. Mitchell here. Today we're going to take a look at one technique of calculating a limit. So let's get started. So we're talking about direct substitution. This is the easiest of all methods of finding limits. So basically, we're just going to directly substitute the number in. So remember how to read a limit. So we're taking the limit of f of x as x approaches c, and then your answer is L. All right. So there's some properties of limits that can be important, that can be very helpful. There's some other properties here for polynomials and rational functions, but we're just going to hop right into it. So it says find each limit. So remember, a limit is as you get close to a number, like an x number. So we're thinking up and down. As you get close to a number, what happens? You have to be going to the same place. You may never get there, but as long as you're getting close to it, then that limit exists. A limit doesn't exist if you're going to two different places like this, or if you're going like this. So this limit wouldn't exist. This limit doesn't exist. They have to be going to the same place. All right. So one of our methods, and there's multiple methods of calculating limits, is just direct substitution. Direct substitution doesn't always work, but we try it. So this is the limit of x squared as x approaches 4. So trying direct substitution, we plug in 4 for x, and we see what we get. So plug in 4. 4 squared is 16. So that's the answer. It's really that simple sometimes. Sometimes when you get into more advanced limits, direct substitution hardly ever works, at least initially. Normally you have to do some simplifying, some other methods that we will look at, and then you calculate it. So again, here's the limit of 5x as x approaches 4, plug in 4. So it's 20. All right. So then we have this one. So we'll plug in pi. And when direct substitution doesn't work is if you plug this number in and you get an undefined fraction or something that you're not allowed to do, and then you have to do some other method to kind of calculate it. So we have pi on the bottom. What is the tangent of pi? Okay. So we can get a limit of 0, that's a number. Can't get 0 on the bottom. All right. So again, if direct substitution works, use it. It's the easiest method. You might as well. Now we're going to plug in 9. You get 3. So we're going to take pi times the cosine of pi. So what's the cosine of pi? Using your unit circle concepts, it's -1, so this is negative pi. Take the limit of x plus 4 quantity squared as x approaches 3. So you plug in 3. Got to make sure we remember order of operations. So that's 7 squared, which is 49. All right. So again, this hopefully seems simple. I hope that it does, but it's going to get more complicated. All right. So we're taking the limit as x squared plus x minus 6 as x approaches -1. All right. So we're going to plug in -1 and square that, and then plus -1 and then minus 6. So this is +1 minus 1 minus 6. That's -6. And then over here, take the limit of this as x approaches -1. So that's -1 squared minus 1 minus 6 on the top. And then you have -1 plus 3 on the bottom. Well, the top is the same thing as it was over here. So it's going to be -6. And on the bottom, you get +2. You divide them out, you get -3. All right. So that's direct substitution for limits. Let me know if you have any questions.